Good morning. I want to work another example problem for you, this time specifically involving momentum. We've talked about momentum and conservation of momentum, and we have to use those principles to solve these type of problems. So in this problem, we have a 25 kilogram object moving at 15 meters per second. It collides with a 15 kilogram object that is standing still. They stick together and keep moving. What is the final velocity? So how do we work this? Well, we have to use a couple common principles, and I want to remind you of our steps to success, how we problem solve in this class. First off, we have to section our workspace, be very neat, okay, and I said we'd like to see the abbreviations and symbology and stuff like that, sign conventions and stuff up on the right upper left hand side. I want to make a drawing. I'm going to label the drawing, state your unknowns and your knowns, start with a question, what you're looking for, and then get started from there. So in this particular one, I've sectioned off my workspace, and as always, I want to make up and to the right positive. Okay, so we have two objects moving. If they happen to be moving in different directions, velocity, acceleration, all of these are vector quantities. You need to keep track of that so you can work the problem correctly. So up and to the right is positive, okay? And then we want to draw a picture. Now, I'd say objects colliding. So they can be just about anything, and that gives us a chance to work on our drawing skills, which is none. Okay, there's two objects, okay? So this is object 2, and this is object 1. And we can go ahead and just label that too. Object 1 and object 2. Everything's straightforward and everybody can understand that. Object 1, which is this one, we'll call it, is moving. It has a velocity, and that's 25, or excuse me, that's 15 meters per second. And it also has a mass of 25 kilograms. Now, to be clear, since we've already said this is object 1 and object 2, we want to use the subscript 1 when we're talking about that mass, that object. This one obviously has no velocity because it's standing still. But it does have a mass of 15 kilograms. And I see I've missed my 5 over here. That's 25 kilograms. Okay? So what do we know? Well, we have all the formulas of motion, and we have the formulas for momentum. And what is momentum? Momentum is nothing more than the mass times the velocity. And that applies to every object. And then we have the conservation of momentum, which states that the momentum before a collision is equal to the momentum after. PA equals PB, or PB equals PA. And we'll just go ahead and put M over here for mass, V for velocity, and we're going to throw that P in there for momentum, A for after, and B for before. So what is the momentum before and after? Okay, well, the momentum before is the momentum of the two individual objects, mass 1 and mass 2. The momentum after is the momentum of this combined because they stick together and keep moving. Okay, so we need to realize that this is a totally plastic collision. So the mass final, or the mass after, okay, is equal to mass 1 plus mass 2. In this particular case, that's just 25 kilograms plus 15 kilograms. So the mass after is 40 kilograms. And that's one mass moving off together. Okay? So we're going to look at the momentum before and the momentum after, according to this equation here. So So the momentum after is just the mass times the velocity, okay? And the momentum before happens to be two separate ones, mass 1, velocity 1, plus mass 2, velocity 2. We're going to keep that B for before notation in there, so we're tracking that, okay? Now, if we look up here at our original problem statement, we realize that this V2 is 0, okay? So we can look down here at this term and cancel that out completely. So now we have 4 terms in our equation. We know these masses, okay? We know this velocity, so all we're trying to do is figure out that velocity. And that's what they're asking for, is the final velocity. So we can just solve, okay? And that just happens to be mass 1, velocity 1, divided by the mass after. Okay, so that's 25 kilograms times 15 meters per second divided by 40 kilograms. You'll note I've been keeping my units all the way through, so now I can easily look and say that kilograms divided by kilograms is 1, and we have an answer that equals 9.375 meters per second. And as always, it's best to box our answer or highlight it or star it in some way so that it draws our reader's eyes to the solution. Thank you.